Okay, again, lesson 8 is on informally fitting a line to data. Because if we have that line, like I said, we can write an equation. We can, excuse me, make some predictions with it. Okay, we can know some of the order pairs, and it might not be perfect, but at least we can use data. Why take data if we're not going to use it? So let's just look at a couple more examples. Does the current in the water go faster or slower when the water is shallow? The data on the depth and velocity of the Columbia River at various locations in Washington State listed below can help you think about the answer. Okay, so we don't have a graph here, okay, but we want to focus on the data. What can you tell about the relationship between the depth and velocity by looking at the numbers in the table? So if I look here at my depth, it looks like these are increasing, right? So, as always, what we can say is as depth increases, what's happening? Well, let's look at our velocity. We start at 1 point, now this is feet per second, right? So at a depth of 0.7 feet, so not even full foot, the water's moving at 1.55 feet per second. At 7.3 feet, so now pretty deep, we're only moving at less than 1 foot per second. And when you get up to 11 feet, we're only moving at 22 hundredths feet per second. Okay, so we can say as depth increases, the velocity is decreasing. Make sure I have correct grammar there. Okay, so this kind of plays into our next question here, because the next question says, if you were to make a scatter plot, what variable would you put on the horizontal axis and why? Okay, well, the key part right there is this. We always want to have our independent, our x value, be the one that's easy to record. Okay, it's the one that we're always going to say is increasing. Okay, so if it's easier to measure, it's easier to plot these points. That, and along with the fact that I've always kind of just done with the fact that whatever in the first column is your independent, your x-axis, or x variable, or x, coordinate, and then the second column is your y coordinate. But really, we always say this depends on this. The velocity depends on the depth. So what variable would you put on the horizontal axis? I would put depth. Okay, I would put depth. Sorry for my poor spelling. This is why I usually just type things out. I would put depth, and the big reason is it's easier to measure. Okay, easier to measure. We're going to say this. We want it to be increasing. Okay, need to see it increasing because as you heard me say over and over, I always draw the arrow on a scatter plot, and then I say as whatever the x variable is increases. And then we can see if our y variable, our dependent variable, what is happening to that, if anything's happening to it. Okay, so now here's the scatter plot of it. Okay, so we want to just choose a point and describe what it means in the context of this. So here's the scatter plot of depth and velocity. So I don't know, maybe choose 2. This one looks pretty easier, right? 2, 1.1. Right, it'll be halfway in between there. Okay, and actually if I look at the chart, it's like 1.11, but that's okay. We're going from our chart. I'm going to say this is 2, that's our x coordinate, and 1.1, which is our y coordinate. Okay, what does it mean? It means, okay, let's do this so I don't mess it up again. The river is 2 feet deep. It's its depth. And had a velocity of 1.1 feet per second. Okay. And where does that come from? Well, the 2 here is our x value, it's a depth. our y value is velocity, so that's where the 2 feet deep and a velocity of 1.1 feet per second. Okay, so it says based on the scatter plot, this is kind of going back to where we were before. Describe the relationship. Do we see a relationship? As our depth is increasing, what big picture in general is happening to our velocity? It's not a straight line. Don't play connect the dots. That's not informally fitting a line. But it's going down, isn't it? So that's what we would say. Based on the scatter plot, describe the relation. As depth increases, the velocity decreases. And if you're ever not sure what to say, always start out with this part here, because we're always reading our graphs from left to right. Okay? So if the river, I should have looked ahead, right? If the river is 2 feet deep at a certain spot, how fast do you think the current would be? 1.1. 1.1 feet per second. That's what I get for not looking ahead, right? Not that you mind. Excuse me. Okay. And again, that just comes from this to 1.1. All right. Use the line to predict the velocity. Oops, forgot. Must have deleted something out. Let's draw a line first. Okay. Now, remember the hint I gave you. You want to get it as close to as many points as possible. With a good, okay, maybe something like that. Okay. Doesn't have to be perfect, but that's kind of not bad, right? I'm trying to get it, I'm trying to fit it in there. That's what it's called, the best fitting line, right? So now using that line, use that line to predict the velocity for a depth of 8.6 feet. Okay, so 8.6, so 8.2, 8.4, oh, nope, that's not how they're going. 8.25, 8.5, 8.75, so 8.6 is going to be in here somewhere. No, it's not. Sorry, let me try that again. This is going to be 9. Okay, so 8.6 is going to be just right here. Okay, so if I use the line to predict it, it's going to be like at 0.65, 0.64, okay, something like that. Oh, I see. Okay, the lines are going up by 0.5, so 0.65, 0.67. Okay, so approximately 6, what did I say? Or 0.65. Now, how far off feet per second there? Well, if we go to the actual, 8.6 is at 0.59. So we're really only off about 0.06, okay? How far off? Only about 0.06 feet per second. So it's really not off that far, which goes to show that using this line can be helpful for making predictions, okay? And we can use this data to maybe drive something else that's going on. Maybe it's a safety issue, maybe we're dealing with wildlife in this situation, but the more data we have, and if we can make it useful data by doing a best fitting line, we can use it to drive whatever our goal is.